So I promise we'll get to making pad stack here, but before we get to that, let's again just, well, not again review, let's actually make sure we review, or talk about, I should say, not review, the two different types of pad stacks we're going to be making. We're making a through-hole pad stack, which is really what we were kind of talking about before, which is where I have a drill hole that I drill, and then there's this copper pad that's around the size. In the previous video we talked about how to determine this hole size and this pad size. Now there's also what's called a surface mount. Now one of the things that is easy to tell the difference between these components because they both look like they're mounted on the top in the sense that the component's going to be on the top side of the board, but for a through hole component it's soldered from the bottom. Where for a surface mount it's soldered on the top. Through hole requires a drill to drill a hole. Surface mount, no hole is drilled. And if we talk about a surface mount pad stack, at this point all we would do for a surface mount pad stack is simply make my copper pad. And so I'm not going to shade this on because I'm going to draw some more things. Actually, the way I've drawn this, I may as well shade this in. So again, these are copper. Now, there are two additional things we need to consider depending on the type of hole that or the type of pad stack we're making. And these are called a solder mask and a paste mask. Now, a solder mask, this is actually different colors, but if you look at a board, a circuit board, and you see that a lot of circuit boards are like green, or you'll see some that are red, or even maybe blue. And there's other colors for solder mask, but that's the solder mask, and it basically covers up. I don't know why I put this in parentheses there. It doesn't really need to be in parentheses. It covers up all of the traces and only leaves the pad stacks exposed. And the advantage of this here and why we do solder masks is it protects the traces so that it prevents the, believe it or not, like dust forming shorts across traces. It protects the traces, also makes it so that it's the board's more robust so that you can't like scratch a trace and break a circuit there. It also makes it easier for it to solder by hand, which isn't the main reason we have a solder mask. But if you're talking about soldering by hand, you don't have to worry about accidentally soldering traces together because the solder mask is an insulating electrical insulator. So, and honestly, solder doesn't even really stick to a solder mask. And then, another reason is basically, well, the main reason just makes it more robust. Now, a paste mask, this is used for surface mount components. And this is really used for an automation process. And what do I mean by that? Well, if the board is being assembled by machines, which most of them are, the first step is that it's actually like a silk screen is what they're doing, except it's a metal screen as opposed to silk. Um, it's this metal screen where they have these little things that have been cut out of the metal, and they basically take solder paste and kind of squeegee over um, over the board, and where all of these little openings are, solder paste will now be on the board, and then it moves to the next machine and the components get placed, and then it goes into an oven, and then the oven basically heats up that solder paste and basically makes the electrical connection for us. Now, what happens is this solder paste is typically smaller than the pad stack, or the not pad stack, the copper trace, the copper pad. And with the solder mask, this is typically larger than the copper pad. Now, there's not a set standard like there is for like the size of the hole for solder mask and paste mask. And the reason there's not a standard, I mean there is and there isn't. There's not just an IPC standard for the sizing of these. There are standards for like the solder masks as far as what you should be using and solder paste and everything else like that. But there's no standard as far as the sizing. And the reason is because depending on the type of solder mask used, um, the size of the solder mask layer will change. Now it won't be significant change, but it depends because like if it's green or red or blue, they have different characteristics. Because what happens is this at least the process we have in our lab, and this is a process that is used, is that basically um, what we do is we actually take a printed circuit board, we coat the entire board with the green stuff, and then what we do is we actually uh, bake it for a little bit to kind of get it in a what's called a preset stage. It's not hardened yet, but it's kind of preset. And then what we do is we have a transparency that has black squares or black circles wherever we want the copper to be exposed. So those that would be where the copper pads are. And we lay that transparency on top of the board, and then we have a machine and we expose then the board to UV light. And what happens is all of the areas that are exposed to UV light get, quote, hardened. And then we bake it again. I believe that's the process. I haven't done this in a while, so I don't remember our exact process. But at some point, we then uh, wash off the board. And basically, because we haven't hardened the portions that had the black on the transparency, those will wash away, leaving it exposed. But the issue is when you quote when you expose it to the UV light, there is some kind of expansion within this solder mask, and the expansion is small, but it's something that we have to be aware of because we don't want to cover up our copper pad with our solder mask because then we can't solder our component on there. So we will be using, though, for our course, we will be using basically that the solder mask here we'll be using is going to be the pad I'll say here, the copper pad plus 0.07 millimeters. So not much bigger, but it is a little bit bigger. So I'll be doing plus 0.07 millimeters for that. And then the same thing happens for the solder paste, is depending on the paste, the size of the solder paste layer will change. And that depends on basically, these all have different characteristics, and when you heat up the solder paste, it's going to have some flow properties where it's going to expand. And we want to make sure that, we don't have the solder paste so big that when it kind of flows, when it gets heated up, that it doesn't basically flow to the subsequent leads and, cause shorts. So we will use just a general rule here, and this is not like a standard by any means. This isn't even really something that's like, oh, this is what I've looked up on a thing, but it's one that we've used before for the solder paste that we use, and it works good, is that we are going to use that we reduce the size of the copper pad by 10%. That's what we're going to do for our solder paste. Now, let's talk about the components again, the different type of things here. So we're going to look at through hole. So what do we need for a through hole component? There's going to be three main things that we're going to need here. We're going to need the drill size. We're going to need the copper pad size. And we're going to need the solder mask. Now, we will be doing a practice, which I think is a good practice, that we're going to be doing these both on the top and bottom of the board. And what this will allow is it will actually allow us to solder a through hole component either on the top side or the bottom side of the board. We're still going to we'll primarily be doing it on the bottom, but that's what it will allow us to do. Okay. For a surface mount component, we also have three things. We're going to have the copper pad size. We are going to have the solder mask size. And then we're going to have the solder paste size. But these are all just going to be on the top. So we're not going to have a top and bottom. Okay, so we're now ready to actually go ahead and actually start making a pad stack and seeing how that works.